Okay, I thought what I'd do is record some solutions to exercise 12D, and particularly the ones here at the end of this exercise 7, 8 and 11. So what I'd like you to do though is attempt these questions and then maybe play back this screencast and have a look at the solutions, and maybe me talking you through those solutions will help with your understanding, but I'd rather you attempted them yourself first, please, rather than just shot straight to this and took the solutions down from here. That wouldn't be very useful for you at all. Okay, so question 7. If you haven't attempted question 7, then do so now, please. Pause this and then come back to it. So question 7, a bag contains 5 white balls, 6 red and 7 blue. 6 red, 7 blue balls. If 3 balls are selected at random. Okay, so we've got 18 balls here. I'll just make a note of that. And we're selecting 3 at random for those spots there. Find the probability they are all red. So firstly, A, all red. The probability that they are all red. Okay, so let's get to work. What we need here is a denominator that's got all the possibilities. So if we're taking 3 balls from 18, is the order important? I suspect not in this case. So it's 18C3 in our denominator, and in our numerator they're all red. So I don't want any whites, I want 3 reds. So there'd be 6C3 ways of coming up with all red. So 6C3, I'm just going to use my desk calculator here just to speed things up a little bit. So 6C3 is equal to 20, and 18C3 is equal to 816. And 20 divided by 816, I got 5 4s there and 204 4s there, so 5 over 204 for the probability that they're all red. So that's 7 part A. Part B, all different colours. So now we want in part B probability all different. So what that means is one of each. Order doesn't matter. So we want 1 white, 1 red and 1 blue. So again, our denominator is 18C3, so there's 816 in our sample space. Right, now how many ways can we choose 1 white from 5? 1 red from 6, and 1 blue from 7. 5 times 6 times 7, which is 210, which we can back down to 210 over 816, 105 over 408, which is 35 over 408, 3's into 408, I'm doing this manually, 136, 35 over 136. I'll pause there and check that. Okay, so that seems to be okay, 35 over 136. So choosing 1 ball from each of the colours. Okay, hopefully we're getting the hang of this now. Okay, so the next question is question 8. Okay, just interrupted there by Mr. Dimsey. Back to work. So we're looking now at question 8, which has 8 digits from 0 to 7. And this one takes a little bit of thought. 3, 4, 5, 6, 7. So perhaps you've had a go at this. If you haven't, please pause and come back to it. So now we're looking for the probability that the number is even. Probability of even. Okay, so for it to be an even number, we're looking at 4-digit numbers. 1, 2, 3, 4. I always find it useful to do that. Now, maybe it's just me, but in this last slot here, for it to be even, 0, 2, 4, or 6, But I think actually if I don't use a 0 in this spot here, I can't use it here. I can't lead with a 0. It's not a 4-digit number if I do that. So I think I'm going to have to consider these cases separately. So what I'm going to do is I'm going to consider the 0 case on its own. So I'll put 0 there. Okay, so I'm just considering the 0 case. Now, in these other 3 spots, because the 0 is taken out, I can have 1, 2, 3, 4, 5, 6, 7 P, because order is important, 3. So that's for those 3 slots there, 7P3. Alright, now that's only for when it ends in 0. I need to consider now other options for when it finishes in a 2, 4, or 6. 2, 4, or 6. So there's, whatever I come up with here, there's going to be 3 options. Now I can't lead with a 0. So if I've taken a 2 out, or a 4 out, or a 6 out, I can't lead with a 0, so now I'm down to 6 options. 6 options. Once I've not led with a 0 there, the 0 comes back into play for the second spot. So I've still got 6 spots available. 5 for this one, and 3 for the last spot, 2, 4, or 6. So I think if I add these together, 7P3, see what we get here. Menu 5, 2, hopefully you're getting good at that. 7, 3, that's 210. And 6 by 6 by 5 by 3 is 540. So if we add those together, we get 750. And we have a total, we have a sample space, if you like, a sample space. Again, we can't lead with 0. So in our 4 spots, I've got 1, 2, 3, 4, 5, 6, 7 possibilities for spot 1. 0 comes back in for spot 2, so I'm 7 again, by 6 by 5, and I've got 750 on top. 750 on 7 by 6 by 5 is 1470. So I've got 750 on 1470. The zeros are going to go, and then I'm going to divide by 3. So I've got 25 over 49, which I think 25 over 49 is not the right. Am I looking at the right question? 8A. Yeah, 25 over 49 is correct. Okay, so the probability it's even is in place there. The probability that it is odd. Okay, let's have another look at the situation here. 1, 2, 3, 4 spots. 1, 3, 5, or 7. I can have any one of 1, 3, 5, or 7 in there. And then in the other spots, I cannot have 0 in the first spot. So after I've taken out my 1, 3, 5, or 7, let's say I've taken out the 1, I'm also now going to take out the 0 because that's not an option for the first slot. So 1, 2, 3, 4, 5, 6 options available here. I now have the same number of options because 0 comes back into play. And now 6 by 6 by 5 by 1, 3, 5 by 4 equals 6 by 6 by 5 by 4, and I get 720 over 1470. So again, doing some simplifying, I'll pause here. We get 24 over 49 once we've divided by 3, and that's the probability for B. Now part C is less than 4,000. Less than 4,000. So my first number, so the probability now, less than 4,000. My first number, I've got a 4-digit number. It can end in, it can't start with 0. it can start with 1, 2, or 3. So my options for this first spot are 1, 2, or 3. My options for spot 2, once I take out one of those options, is I've got any one of the other options available to me, and that is, so I've got 7 options available to me in this spot here, and 6, and 5. So this is 3 times 7 times 6 times 5, which gives me 630. Again, over 1,470. I'll pause to check the calculation, and we get 63 over 147, or 3 dividing by 21 sevenths. Okay, so we're down to question part D now, and I'll just talk you through this. We're looking for the probability that the number is less than 4,000, given that it is greater than 3,000. So what that means is we now need to change our sample space. It can't just be any number anymore. We're only considering numbers in our sample space that are greater than 3,000. So the easiest way to find that, I think, is to take our whole sample space, which is 1470, which we've been working with, as you can see in parts A, B, C, and we're going to subtract the numbers that are less than 3,000. That'll give us the total number of numbers, 4-digit numbers, that are greater than 3,000, which is our sample space here. So we work out the numbers that are less than 3,000. Here's our 4 slots here, 4 available slots. Now our numbers have to start with 1 or 2. For them to be less than 3,000, it can't start with 0. So 1 or 2, so there's 2 options for slot 1, and then in these 3 slots here, we've got 7 digits, and we need to choose 3 of them, so there'll be 7 P3 combinations of those, or permutations in this case. 2 times 7 P3 gives us the number of numbers less than 3,000. Subtract that from 1470, gives us 1,050. That's our sample space. That is now our denominator here, because now we want to know how many of our 1,050 are greater than 3,000. Sorry, is less than 4,000. So that has to start. That's a number that has to start with 3, because we're only considering numbers greater than 3,000, and we want to know how many of them are also less than 4,000. So it starts with a 3. So there's only one option for the first digit, and then you've got 3 options. You've got 7 digits to fill those 3 spots. That's 7p3. So 1 times 7p3 is 210 over 1,050. Simplifies to 1/5. Okay, we go to question 11, which is a committee of 3 is to be chosen from a group of 4 men and 5 women, and there's the 3 slots there. 4 men, 5 women. Part A is asking for the probability that the committee contains all women. So we look at the sample space, the denominator, that represents all the ways of choosing a combination of 3 from 9. So because we've got 4 and 5, we've got 9 total. So a committee of 3 from 9 people, and it doesn't matter what sex they are, because our denominator is all the possibilities, so it's 9C3. In the numerator, we're looking at the number of ways of selecting 3 women from 5. So because they're all women, 5C3 over 9C3, 10 over 84, or 5 over 42. Now in part B, we are looking at, see, I've lost part of my screen there. In part B, we're looking at the probability that it's at least 1 woman. And now whenever you see the words at least, you think of the complementary event. So in this case, let's say 1 minus no women. So 1 minus all men. So all men. What's the probability that all 3 are men? Well, there's 4 to choose from, 4C3 over 9C3. That's the probability they're all men, which is 1 over 21, because 4C3 is, what number is that? That's 4. 4 over 84, which is 1 over 21. So we subtract that from 1, we get 20 over 21. That's the probability of all men. I'll just refresh my screen. I'm pausing. Now in the last part, 11C, exactly 2 men. The probability that the committee contains exactly 2 men, given that at least 1 man is chosen. So again, as soon as questions say given that at least one man is chosen. In the last question, it was given that the number is greater than 3,000. Our sample space changes. It's not 9C3 anymore. We know that one man has been chosen. So my method here is to look at the number of ways we can choose one man, which is 1 from 4 men and 2 from 5 women. The other 2 are going to have to be women. That's going to be there's going to be 40 ways of doing that. 2 men chosen, so 2 out of 4 with the 1 woman from 5 gives us 30 options there. And all men, there's 4C3, all men and no women. So there's only 4 of those options. So our sample space is 74. That's our sample space. So we have to go and work it out first. That's 74. So that goes into the denominator. And how many of those 74 have exactly 2 men? Well, the 2 men chosen is this here. So 30 of those 74 are exactly 2 men as part of the committee. So that's our probability. 30 over 74 reduces to 15 over 37. I hope that's helped with your understanding. Have a fantastic break from school. I'll see you in July.